connect our program to the command line, because we know that from the command line we can do a lot of things in terms of calling programs, redirecting input and output, running things multiple times, and piping things together. So if we can modify our program to use command line arguments, then we don't have to go in and change things inside the program every time we want to change it. We can have some variables that change and are set up from the outside of the program. So that's where we're going with task 2. So we've downloaded repeatdosage.py from Blackboard, so that's sitting there. We can have a look at that program, and we can see that it's got our code that we used previously, but what we're going to be doing is changing this so that the interval and the dosage will come from the command line. The first point for doing this is to start by importing sys, which will give us access to sys.argv, which are the arguments for the input values. So I might just put a little bit of detail here, so we can say that this gives us sys.argv with sys.argv 1 being the first argument on the command line, and sys.argv is just a list of strings. So rather than have you watch me type, I'll cheat a little bit. And this is just coming from the prac sheet. So the first line there is the if statement is checking to see how many arguments have been put on the command line, and if that's less than 3, it will say that you haven't really put the command arguments on the command line, so we're going to use some default values. Okay. So we'll have v-interval that we're going to be using to have these variables coming from the command line. V-interval equals 8 and v-dosage equals 100, so they'll be our default values if the user doesn't put something on the command line. Otherwise, we're going to take those command line values. So int sysargv1 is the first value put on the command line after the name of the program, and v-dosage sysargv2 is the second argument. So the next step is that we need to connect up our command line arguments that have gone into v-interval and v-dosage to our actual variables that we use in our program. And this means we don't have to make as many changes through our program to have it use a different variable. So we can say v-interval interval equals v-interval. I'll just change that to hours between dosage, and here dosage equals whatever the dosage amount is, so that's v-dosage times 1,000. Okay, if you don't keep the times 1,000 in there, you will have a graph that has just a line that you can't see because it's right on the bottom axis. So just that's something to check, is that you've got them multiplied by 1,000 there. Okay. So for now that should be all the changes we have to make. We'll just see. So if I use Python 3 repeat dosage, see that program's running, and that's our values, and they're our default values coming in because I didn't put anything on the command line. So it's using 8 and 100. To show that it will do something different when I have command line arguments. So sysargv, when you run a Python program, sysargv0 will be the name of the program, repeat dosage p.py, so you can always get that value. And then if you wanted to have 50 every 4 hours, and run that. Nope, wrong way around. So you can see it did make a difference because we've got this lovely every 50 hours getting a dosage of 4, which is not effective at all. So let's try 4 and 50. And you can see that we have a similar graph to the previous one, but time between dosages is smaller and the amount of the dosages is smaller, so we don't have as big a swing in our concentration in our blood. If I change that to be a dosage of 500 every 4 hours, you can see that that is way too much. We have our mean effective concentration, MEC is the green line, mean toxic concentration, the red line, and now we've gone way beyond that after pretty much our second dosage taken us into the toxic area. So that wouldn't be a good description to give. Okay, something else to look at is that we've got some overall statistics at the end of the program. So looking at the minimum post-effective value. So after it's become effective, how far down does it swing? The maximum post-effective value, after it's become effective, what's the maximum value? And you can see that this is way above our toxic range and the average post-effective value. So you can see where that middle of the swing would be with the program. So this is some very basic post-processing to give us some values, and then later on we'll be putting these saving them into text files so that we can access that information rather than having to run them all and read each of them off. And for the overall, the mean value is 0. So these later statistics are better and we're effective at 1 hour, which is way too soon, which is a sign that you've got the dosage wrong. Now if we wanted to save the figure so that we can get that back rather than rerunning everything, we can go back in and edit repeat dosage. And we know that we've got V interval and V dosage that hold our values that we're interested in. And with savefig, we have to do it just before the plot show. Okay, so we just in here do a plot.savefig, and the code is in the prac sheet. So we'll take dosage. We're creating a file name here. So it's going to start with dosage underscore. We're just building up a string. You see what's happening. So it's going to be dosage underscore plus I for interval, and we're going to convert the interval, which is a number at the moment. So I is for interval, and then string B interval to get that value out of that number and convert it to a string, so we can use plus signs to concatenate it all into one big string. So adding that to underscore D, so we'll have dosage underscore I and the number for the interval underscore D, and we'll add to that the number for the dosage. Okay, so that's the start of our string, and then we'll add the extension because we want a PNG file for our graphics, our plot to be output to. So now we can not only have the figure show up on our screen, we can have it saved. And then later, if we're doing lots of these, we will suppress that image come back up on the screen and we'll just do the save file. So looking at that, if we rerun, do one that's closer, 4 and 100. So you can see I can change the command line values and get a different graph each time. So that's looking at our dilantin concentration, and this time we are certainly over the toxic concentration, but not as much as that previous one. If we close that and look at our files, you can see we've saved dosage I for D100.png. On my Mac I can just use open to have a look at that. And this is the image of the plot that's been saved. So that's all that you needed to do in task 2.